When people hear artificial intelligence, they usually think about code, data, or massive neural networks. But underneath all of that, AI really speaks just one language: vectors. Vectors are how AI stores information, compares meaning, and makes decisions. If you understand vectors, suddenly a lot of AI stops feeling mysterious and starts feeling geometric. So, in this video, we are going to build an intuition for vectors, not as scary math symbols, but as the native language of AI. The confusion usually starts. Ask a physicist what a vector is. They'll draw an arrow. Ask a computer scientist. They'll show you a list of numbers. Ask a mathematician, and you'll get abstract notation. Same word. Three different mental models. And AI quietly uses all of them at once. The key to understanding vectors in AI is realizing they're not either arrows or numbers, they're both. AI doesn't think in words or concepts the way humans do. Instead, it translates data into geometry. Each data point becomes a position in space, each idea becomes a direction, and suddenly, learning becomes a geometric problem. Which things are close, which are far apart, and which point in similar directions. This geometric view is what makes vectors so powerful. One way to think about a vector is as a set of instructions. Start here, move this far to the right, then move this far up. That's it. The arrow you see isn't the vector itself, it's just a picture of those instructions. And this idea will scale beautifully when we move beyond simple 2D space. Mathematically, a vector lives in something called r to the n. That sounds intimidating, but it's actually simple. It just means instead of two numbers, you might have hundreds or thousands or even millions of dimensions. AI models don't live in 2D or 3D, they live in very high dimensional spaces. Here's one of the most important ideas in AI: meaning isn't measured by distance, it's measured by angle. If two vectors point in similar directions, AI considers them similar in meaning. That's why dog and cat end up close together. Not because they're the same word, but because their vectors point in similar directions in semantic space. This is the foundation of embeddings. Let's make this concrete. Suppose you describe a house using numbers: square footage, price, maybe location. AI turns that list of numbers into a single arrow in space. That arrow represents the entire house. Compare arrows, and you compare houses. This is how recommendation systems, pricing models, and predictions all begin. Notation matters. A lowercase v usually means a single number, a scalar. An uppercase or bold v signals something different, a vector, a list of numbers with direction and structure. These visual cues help you immediately know what kind of object you are working with. In textbooks, vectors are usually written in bold. In handwriting, we often add a little arrow on top. Different styles, same idea. Whenever you see that arrow or bold symbol, your brain should switch modes. This isn't just a number, it's geometry. By convention, vectors are written as column vectors. A row vector is really just the transpose, the flipped version. This might feel arbitrary at first, but it becomes essential when we start multiplying vectors with matrices. And AI math relies heavily on that structure. Column vectors fit perfectly into matrix multiplication. That's why neural networks work at all. When dimensions align, multiplication is valid. When they don't, the math literally breaks. This isn't just notation preference, it's structural necessity. Let's pause and test your intuition. You see this arrow ending at -4, 2. How would you write that as a column vector? Think of it as instructions. Left 4, up 2. If you can translate between arrows and numbers, you're officially thinking in vectors. One last subtle but important point. Code syntax and math syntax are not the same thing. Writing a vector as a list works perfectly in code, but in math, placement and orientation matter. Mixing the two without understanding why leads to silent bugs, the most dangerous kind. Let's summarize. A vector is an arrow and an ordered list. It's written in bold, usually as a column, and it's rooted at the origin by default. If you remember just these ideas, you already understand more vector math than most beginners. Now that we know what vectors are, the next question is, how long is a vector? How do we compare magnitudes, normalize directions, measure distance and similarity? That's where vector magnitude, unit vectors, and distance come in. And that's exactly what we'll tackle next.